Every day, millions of people use a bar like this, without ever knowing where it truly begins.
Its whiteness hides one of the oldest industrial transformations on Earth. Before it reached this clean factory floor, every bar in this row began somewhere far less visible. For more than 2,000 years, humans have turned animal fat and alkaline minerals into soap.
On ingredient labels, this transformation often appears under one technical name: sodium tallowate.
Across America, hidden rendering plants quietly turn animal byproducts into ingredients used by everyday industries. One material can become soap, candles, lubricants, feed ingredients, and industrial products, a quiet form of biological recycling.
This ordinary-looking bar has one of the most unusual journeys in manufacturing, from cattle bone to clean, hard soap. To understand how this bar is made, we have to follow the process backward. Before the soap, before the tallow, before the factory.
The journey begins in the American Midwest, where cattle operations generate large volumes of bone and fat byproducts every day.
After meat processing, the remaining skeletal material is collected, sorted, and prepared for rendering. Bones can represent a significant part of the animal's remaining material, and in rendering, they are not treated as waste.
Kept cold and moved quickly, the raw material is loaded for transport to a rendering facility.
From the outside, it looks like any other refrigerated truck. Inside, it carries the beginning of a product most people use without question. At facilities like this, the transformation happens out of public view, not because it is magical, but because it is industrial.
The bones arrive in bulk, here, sorted, chilled, and ready for the first mechanical stage. Before crushing, the material is sorted by size, so the machines can process it evenly.
Each batch is washed to remove surface residue before heat extraction begins.
Inside material like this are fat residues and organic fractions that rendering can separate, purify, and eventually turn into soap ingredients.
The first major mechanical step is size reduction, breaking hard bones into fragments that heat can penetrate faster.
Once crushed, the bones become smaller, more uniform material, ready for steam, heat, and separation.
Live steam is injected directly into the crushed material, transferring heat quickly and beginning the fat separation process.
Inside these sealed systems, heat forces fat, water, and solids to separate from one another.
As the mixture heats, fat rises naturally, creating a golden layer that can be separated from water and mineral solids.
This is crude tallow, the fat fraction that will be cleaned, tested, and later reacted into soap.
Filtration removes fine particles before the tallow moves into high-speed separation. Centrifugal force completes the separation, fat, water, and solid bone residue leaving through different paths. At this stage, the tallow has become a controlled industrial ingredient, stored warm until the soap process needs it. Before any batch enters soap production, the tallow is tested for consistency, purity, and reaction behavior.
At room temperature, tallow stays firm. That hardness is one reason it has been used for dense, long-lasting soap bars for centuries.
Now the rendered tallow meets sodium hydroxide, the alkaline solution that turns fat into soap. At the molecular level, the fat is being broken apart and rebuilt into soap, with glycerol released as a valuable byproduct. Traditional soap cooking is slow. Heat, time, and mixing help the reaction finish completely. Salt helps force the soap phase away from water and glycerol, concentrating the clean soap base.
Removing excess moisture turns the soap base into dry pellets that can be milled, blended, and shaped.
Fragrance and finishing ingredients are added only after the base is stable, dry, and consistent. Milling refines the soap, removing graininess and creating the smooth feel people expect from a finished bar. The plotter removes air pockets and compresses the soap into a continuous, dense body.
For the first time, the material looks like soap, a continuous warm log ready to be cut into bars. The cutter divides the warm log into identical bars, each one controlled by weight, length, and shape. Stamping gives the bar its final shape, surface identity, and tactile feel.
What began as hidden byproduct has now become something familiar, clean, solid, and visible.
The bars rest and cure, losing moisture slowly as hardness and durability increase.
Every bar is checked for weight, density, surface finish, and shape before packaging. Packaging protects the finished bar and prepares it for storage, shipping, and sale.
Dozens of bars can be wrapped every minute, each one leaving the line protected and uniform.
From raw bone material to rendered tallow, from soap base to wrapped bar, the industrial journey is complete.
Human hands still guide the final arrangement, making sure every box is packed evenly.
Sealed cartons move from the packaging line into warehouse storage, ready for palletizing.
From a single production cycle, thousands of bars can leave the line. Enough soap for homes, hotels, hospitals, and stores.
The same supply chain that brought raw material in now sends finished soap out into the world.
Factories like this run beyond what most people ever see, turning hidden byproducts into everyday materials around the clock.
Even in mass production, the final test is simple. The bar must feel right in the hand.
From cattle byproduct to rendered tallow, from chemical reaction to finished bar, this is industrial recycling at its most efficient.
What looks simple on the surface can carry an entire hidden chain of farms, trucks, machines, chemistry, and human precision.
And that is how bones become soap.
Every stage depends on controlled heat. Too little and separation slows. Too much and quality suffers.
In rendering, pressure and temperature are watched constantly because consistency decides the quality of every later soap batch. Behind the visible machines is a hidden network, moving heat, pressure, and material from one stage to the next.
Even after tallow is removed, the remaining mineral-rich solids can become bone meal for other industrial uses.
At this scale, the factory works like a living system, monitored from above, controlled from every level. The process does not create only soap material. Glycerol and other fractions can be captured, refined, and used elsewhere.
After drying, the soap base becomes a material that machines can blend, mill, and shape with extreme consistency.
Once wrapped, each bar becomes part of a larger flow, counted, boxed, sealed, and shipped.
The finished product now enters distribution, no longer raw material, but inventory. Behind every shipment is a record, batch checks, inspection points, and quality controls.
Every day, the cycle repeats. Raw material in one side, finished industrial goods out the other. A good tallow-based bar is firm, dense, and slow-wearing, qualities built during rendering, saponification, milling, and curing. The transformation begins with hard mineral structure, broken down so heat can reach what remains inside. This golden fraction is what the soap process needs, purified fat ready for controlled chemistry.
The final shape is not carved by hand. It is pressed into consistency.
From above, the system looks simple. Material enters, machines transform it, and finished goods leave.
Before heat extraction, Washing removes surface residue and makes the process more predictable.
Preparation here is simple but essential. Cleaner surfaces allow heat to work more evenly later. Small changes at the surface make later extraction more efficient.
Direct steam contact transfers heat faster than air or surface heating alone.
At first, separation is almost invisible. Small droplets rise, gather, and slowly become a usable fat layer.
Once enough fat gathers, it can be removed from the surface and sent forward for purification.
Filtration is repeated in stages, removing smaller particles each time.
The separator depends on speed, spinning the mixture so each fraction moves to its own outlet. One incoming stream becomes 3 separate industrial paths. Fat, water, and solids are no longer mixed together. From this point forward, the tallow is no longer raw output. It is a managed ingredient.
Stored warm, the tallow stays ready for the next stage. Temperature control keeps it consistent before soap making begins.
Testing confirms that the batch will behave predictably when it reacts with alkali in the soap room. The same material now enters a cleaner, more controlled room, where chemistry will turn it into soap.
Soap begins when fat meets an alkaline solution under controlled heat and mixing.
This is the moment the ingredient stops being fat and begins becoming soap.
As the reaction develops, the mixture becomes heavier, creamier, and less like oil. Soap cooking cannot be rushed. Time, heat, and mixing finish the reaction completely.
Salt helps separate the soap phase from excess water and glycerol.
Removing water prepares the soap for shaping. A drier base can be milled, blended, and compressed accurately.
Now the soap base is dry enough to handle like a solid material. From here, machines can refine its texture.
Only after the base is stable are fragrance and finishing ingredients added.
Milling begins the texture transformation. Separate pellets are pressed into one continuous material.
Milling removes graininess and turns separate pellets into one smooth, uniform material.
Repeated milling makes the final bar feel smooth against skin, instead of rough or crumbly.
The plotter removes trapped air and prepares the soap for a perfect continuous extrusion. From here, the soap finally has the geometry of a bar, long before it becomes individual pieces.
At this stage, timing controls everything. Each cut defines the weight and length of the finished bar. Stamping gives each bar its final feel. The shape of your hand recognizes instantly.
Before packaging, the bars must rest, moisture balancing, hardness increasing, shape stabilizing.
Spacing matters. Air must reach every bar evenly, so the cure is consistent. The most dramatic part of the journey is already over. Now the bar gains strength quietly.
A finished bar must pass by sight, weight, touch, and shape before it can leave the factory.
Alignment must happen before wrapping, because even a small shift can ruin the fold.
At this speed, the machine folds, tucks, and seals in a fraction of a second. Every finished bar must look identical.
After wrapping, the bars are counted and packed, so each carton carries the same finished quantity.
Wrapped and stabilized, the pallet is ready to move without losing its shape.
The journey that began with hidden byproduct now ends as a finished bar headed into ordinary life.